So let's figure out what the magnitude here of the work done is. The work done, the magnitude of the work done, and our charge is 3 times 10 to the minus 6. Remember, this is the charge that we're moving now between the delta V caused by the other charges. So to find delta V, we used Q1 and Q2. Now we're done with Q1 and Q2. We've got their contribution incorporated in our delta V, and we multiply by Q3. Let me put a 3 there just to make it clear. We multiply by Q3 to get the work done in moving Q3 between the delta V caused by Q1 and Q2. I think I got that right. You might want to rewind and listen to it again. It's getting a little confusing there. But I'll punch in some numbers. I think you'll see what I mean. So there's our delta V. That's Q3. I multiply them out. I got 2.37 times 10 to the minus 2 joules. And now we need to figure out what the sign is. Is it positive or negative? So the first thing we can do is kind of think through this. This is a positive charge. Let's look at our diagram. This is a positive charge, Q3. And Q1 is also positive. And Q2 is negative. And Q3 starts out close to the positive charge, and as it moves to its final position, it gets further and further away from the positive charge, and it gets closer to the negative charge. So a positive charge, the field here, if we just let go of Q3, is it going to naturally go? If we sort of attached it to a little track that ran between the starting place and the ending place, would it naturally go there because of the field? Yes. In this case, the answer is yes. It wants to get away from this positive charge Q1, and in moving from its starting point to its ending point, it is moving away from Q1, and it wants to get closer to the negative charge, and it would be getting closer. So if we just let go of Q3, and it was attached to a little track here that ran along the side of this cube, it would end up at the corner AA, at the ending location. The field would push it that direction or pull it in that direction, however you like to think of it. And so the field is doing positive work because the force that the field is applying to Q3 is in the same direction that Q3 is moving. The field is doing positive work. Q3 is going faster and faster and faster as it moves from the starting point to the ending point, and it's losing potential energy. So the field would be doing positive work. But when we think about work, we like to think about the particle starting and ending with the same speed. So think about if the particle starts at rest and we let go of it, it's naturally going to start moving towards the corner of the square here, the final corner of the square, AA, x equals A, y equals A. And as it moves there, it wants to go faster and faster. So we would have to reach in with an external force and pull back on it, apply a force opposite the direction that this particle is moving. So we would be doing negative work on this particle by an external force to have it end at rest. If it starts at rest, we want it to end at rest. So the field would be doing positive work on that particle. Our external force would be doing negative work on that particle. So that's one way to think about it. Sometimes the situation is kind of complicated, and you can't tell maybe whether it's getting closer to the positive or closer to the negative. And so let's take a look at some numbers. And what you can do then is look at the numbers. Look at your initial potential energy. Look at your initial potential and your final potential. In this case, the initial was 11.6 kilovolts, and the final was 3.7 kilovolts. So we knew that this particle was going from high potential to low potential. And a positive charge wants to go from high potential to low potential. The field will push it in that direction. So the field will do positive work moving it in that direction, and an external force would do negative work. They're always opposite. A negative charge does not want to go to lower potential by the field. The field wants to push a negative charge to higher potential. So if Q3 was negative, then the field would be doing negative work, and the particle would not go in that direction by itself. Well, an external force would have to reach in and push it that way to get it to go there, and the field would be pushing back, opposing that. So the external force would be doing positive work, and the field would be doing negative work. It's important that you go over that a few times, and when you're thinking about work, think about, what direction is this particle moving? Is the field pushing it in that direction? Because we know that when the force and the displacement are in the same direction, the work is positive. And when they point in opposite directions, the work is negative. And so just think about that. Think about which way the particle is moving, and is the field if you let go of the particle, would it naturally go in that direction because of the field? Then the field is pushing it in that direction. We have positive work. If it wouldn't go that way, then an external force would have to reach in and do the positive work, and the field would be doing negative work.